Hello, my name is Сейлхан Айша and I am a part of NIS Kokshetaus team.
We are members of NIS team and my name is Салемова Хадиша.
I am Ерназаров Елдар.
Today we would like to present you our project work. Carbon emissions are getting bigger every year and the problem of Earth's pollution is getting more serious. When we picture the stuff that is hurting our planet, what do we think of? Smokestacks, cars, oil spills. But we don't really think about the harm of all food we throw away. Roughly, about 40% of the food we produce never gets eaten. That's over 365 million pounds of food each day. All of the wasted food has a huge contribution to climate change. If global food waste were a country, it would be the third largest emitter of greenhouse gases, so it's really an enormous problem. It takes a ton of resources to produce food. On top of that, we have all of the energy it takes to keep it cold and transport it around the country. This is a great amount of money and efforts. When food decomposes, it releases potent greenhouse gases, such as methane or carbon dioxide, and these greenhouse gases cause global warming. As you see, consumers collectively make up the largest portion of food waste. That means that almost a half of wasted food comes from restaurants, cafes, and our homes. We shouldn't be wondering about the amount of food that we waste, because sometimes we all buy food without thinking, do I really need that? For example, meat. Meat is less as percentage of what we buy, but when you consider it in particular as a greenhouse gas intensive product, meat waste actually has the highest greenhouse gas impact. Growing amount of food waste is also related to two factors. Refrigerators have grown about 15% since 1970s. Also, the average dinner plate has grown by 36% since 1960s, which also leads to an increased portion size. We've got used to these gigantic portion sizes at restaurants, and it encourages us to overeat and throw away a lot of food. This problem is getting bigger every year, and to understand its size, imagine the world's largest football stadium filled to its absolute brim. That's how food goes wasted every single day. The leftovers we throw away rot and emit a huge amount of greenhouse gases. Improper disposal of food is one of the most pressing problems at the moment, and it requires immediate solution. We would like to contribute to the solution of this issue by our project work. The aim of our project is to create a smart system for processing food waste and converting it into fertilizers. To achieve this aim, we had several tasks. Task 1. To determine the possibilities of modern technologies for creating a 3D model of smart system. Task 2. Create a scheme for operation a smart conversion system. Task 3. Write an algorithm of conversion system. Hypothesis is the creation of smart food waste recycling system will be able to solve the problem of reusable food in restaurants, cafes, and canteens. We had several research stages. First is study the literature on the research topic. Second is analyze the collected information and data. Third is mental modeling the results. The difficulty of our project is that when creating the project smart system for processing food waste, a new improved system with built-in sensors inside and the device for regulating the processing process was proposed. The degree of autonomy. During the research, assistance was provided by our supervisor, biology teacher. The practical value of our project is an improved smart system for converting food waste into fertilizers can be proposed as an alternative way to recycle food waste.
To begin the process, waste must be placed into the system. Waste receiving compartment is located in the restaurant to achieve the maximum convenience. So staff members do not have to go far to dispose of the waste. This is followed by 4 main conversion stages. First is grading, then goes mixing and dehydration, then additional drying and distribution. Now we will elaborate on each stages in more detail.
In the first stage, the food waste passes through the shredder and then proceeds to the second stage, where rotating elements mix them under influence of hot air. Found here is the ultrasonic sensor, which is responsible for the operating, opening and closing of the doors that allows the received mass to pass into the next compartment. At this point, it should be emphasized that in order for the resulting mass to be considered as a fully fledged fertilizer, it must undergo fermentation. According to our research, there are two optimal methods of accomplish this. The first method involves the use of California worms, and the second involves microbial fermentation. If we opt for the method involving microbial fermentation, this compartment will have to be modified so that a shredded waste trigger system and an additional inlet valve for adding microbes will be added.
During the third stage, additional drying takes place. This requires the waste passing into the drying conveyor, where it will gradually transfer to the distributor mechanism. Here it will be further processed with the assistance of UV lamps and hot air. Air is supplied from distributor area and discharged from two valves. First is controlled drying and the second one is heat treatment. If California worms are used, then the food mass will move along a horizontal conveyor belt. So worms from a worm farm above will simultaneously drop onto the food mass, so it moves along. This conveyor is angled in a manner that ensures that the worms move in a specific direction, that ensures that they will process everything on their path. So when the worms arrive at the distribution mechanism, they will be turned into fertilizer by means of heat treatment. This is the step utilized valve number 1 and has temperature range 55 and 75 degrees Celsius.
The last stage is transformation and necessitates the spreading mechanism, which transfers the fertilizer to the containers of the vertical conveyor. There are two ultrasonic sensors installed here. The sensors serve the purpose of collecting information regarding the amount of fertilizer in front of the spreader. When the amplitude of these values exceeds a certain threshold value, the distribution mechanism will begin. The fertilizer will be transferred to one of the containers of the vertical conveyor, which in turn transfers the fertilizer to the surface.
After the dispensing stage, the program assigns the current container the status field. The conveyor moves the containers forward until the position of the dispenser is occupied by the nearest empty container, and so the cycle continues. To collect fertilizer from the container, you need to access two windows. First is a protective window to prevent the accidental opening, and the second a window with a touch sensor that is associated with the counter. When the second window is opened and fertilizer is removed, the program assigns the value empty for the current container.
The fullness of the containers is depicted on the display located near the first window of the receiving box. Each container has its own tag, and the display will show the full status of each container. If necessary, it will be possible to call an already filled container to the receiving box. If all the containers are full, the spreader will not work and the conveyor will change the position of the containers occasionally so as to store the fertilizer under equal conditions. Thank you for attention.